So in this example, I want to look at wedges. And a wedge is really a device that is often used to create some type of mechanical advantage. An example is like this one shown with this wedge. We have a small force P that can potentially produce a large vertical force to help lift up an object. And a screw is in fact actually a type of wedge. The threads act as a wedge for the system. So we see here we have this object, and if we push in with P, this blue block will raise up some, and it will be raised as this block is essentially going forward, right? If this wedge were going forward, I've moved it too much, right? But you get the idea that that block would move forward if there was space for it to do that, right? So let's look at this example. We have two blocks, A and B. Each have a 2 kilogram mass, so we'll need to convert that to newtons. All contact surfaces have the same coefficient of friction, and we're supposed to determine the force P needed to cause impending motion of block B to the left if the coefficient of static friction is 0.3 again. All right, so we're going to have impending motion of block 3. If B moves, though, we also know that A has to move. We'll start by drawing a free body diagram, and I'm going to break this out into the two blocks A and B and draw those free body diagrams separately. Okay, so here we have the two free body diagrams for block A and B. Now we need to add the normal forces and the frictional forces for these two blocks. I always like to start with the block that is actually moving, that we know is moving, and that would be the bottom block. Typically we'll start with the bottom block and finish its free body diagram first. With that, we have a normal force to the bottom surface due to the weight, and then a frictional force wants to impede that motion due to that force P. So this will be F1, we'll call this, and then this N1. Also on this top surface, this angled surface at 20 degrees, we have a reaction between our block A and block B. So we also again have another normal force. Again, this is perpendicular to that surface. I'll call that N2. And then there is this frictional force on that surface, F2. And that is in the direction of impeding that motion again. Now we can go and finish our top block A free body diagram. We will put in our normal force that we know between block A and B. That will be N2 again. We have equal and opposite direction for our frictional force. So this is F2. Oops, sorry about that. That's F2. And then last, we will know this block is going to want to move up. So we will have a frictional force that wants to impede the motion up. This will be F3. And then a normal force, N3. So again, the trick to this in being able to figure out the directions of these frictional forces is to start with the block that we know for sure what's happening. So it said that it was impeding motion on block B. It wants to move to the left, so we have those two frictional forces. Then we have equal and opposite between the two blocks, and then we know block A wants to lift up as block B moves to the left, so we want to impede that motion also. The last bit of information that we have again is our static coefficient of friction. It was given as 0.3 for all surfaces. So where do we start with this type of problem? Typically I like to start with the block A, the one on top, and kind of work down. So let's look at that. Let's start with block A, and we can write our equations of equilibrium. So I will write them for summing of the forces in the X and Y direction. So here I have my equations of equilibrium for block A. I have my sum of the forces in the Y direction. This W is this 19.62 newtons, and then I have my sum of my forces in my X directions. I've labeled them as equations 1 and 2. Next, I want to look at block B and write my equations for block B. Okay, so if we look at this, I've written my equations now for block B, summing my forces in the y direction and summing my forces in the x direction. And I've labeled these as equations 3 and 4. If we look at the number of unknowns that we have for this setup, we have essentially 7 unknowns. We have the pair of 2 down here, 2, 4, 6, and then we have P itself is an unknown. So we have 7 unknowns. But we do know something about this situation, and what we know is that we have impending motion. So if we have impending motion, we have our equation or our knowledge about F1 relative to N1. So we have our equations for the frictional force. Let me write those out. So I've written down the equations here, which I will call 5. This set of equations then I'm going to take and plug into equations 1 and 2. So I'm going to plug into equations 1 and 2, and I will show you what we get out of that. So here are the new equations, 6 and 7, again after plugging in the equations 5 into 1 and 2 into those two equations. We get this. And here we see we have unknowns of N2 and N3 is all we have is N2 and N3. And if I want to solve these simultaneously, there's multiple methods, of course, setting like N3 and to N2 and solving it that way. Another method in this case, I could take the second equation and multiply through, this should equal 0 here, and take that and multiply this whole thing by 0.3. And if you see that, this will now factor that into each of these terms, and then I can eliminate this N3. If I do that then and work out the rest of the math, which I'm not going to go through, we will get our results for everything. And if we, again, finish that, we can solve for all of these values and get our force P. So just to kind of recap, the big key in here is being able to draw our correct free body diagrams, look at the block that we know is moving in which direction. We have our frictional forces impeding that motion. Then we look at the top block and then draw at our equal and opposite force between these two wedged blocks. And then looking at the motion of block A, the other frictional force. We know it simultaneously. If block B moves, block A has to move. Then from there, of course, we write our equations of equilibrium for block A and B. Substitute in, because we know it's impending motion, that F equals mu n into our equation, and then solve these simultaneous equations to get our results. If you have questions, please let me know.